Every single electric vehicle battery on Earth depends on one critical element, lithium. But our current methods of getting lithium are slow, dirty, and consume massive amounts of water. Today, we are exploring direct lithium extraction, or DLE, a breakthrough technology that filters lithium from underground brine in just hours while returning the water safely back to the Earth. As countries transition away from fossil fuels, the demand for lithium-ion batteries is exploding. Industry experts predict we will need 5 times more lithium by the end of the decade. But traditional mining is slow. Building a conventional mine takes nearly a decade. If we cannot extract lithium faster, the entire transition to clean transportation will grind to a halt. Right now, most of the world's lithium comes from salt flats in South America. They pump salty water, called brine, into giant open-air ponds and wait up to 2 years for the sun to evaporate the water, leaving lithium behind. DLE replaces this slow process with a closed-loop filtration system that takes less than 2 hours, using virtually no open land, and returning the water underground. Solar evaporation is cheap because the sun does the drying work, but it is an ecological disaster. Evaporating water in extremely dry deserts drains local water tables. Fresh water from surrounding mountains leaks into the salt flat to replace the pumped brine, drying out agricultural wells and destroying fragile local ecosystems, including flamingo nesting grounds. Direct lithium extraction is elegant and consists of 3 simple steps. First, salty geothermal brine is pumped from reservoirs miles beneath the surface directly into sealed filtration tanks. Second, the liquid flows over chemical filters coated with absorbents that act as atomic magnets, grabbing only lithium ions. Finally, the remaining brine is immediately pumped back underground. How do we pull lithium out of a liquid filled with dozens of other salts like sodium and magnesium? The secret is adsorption. DLE filters contain custom-engineered beads with microscopic cavities that match the exact atomic size of lithium. Other salts are too large or too small to fit, so they flow past, while the lithium slides in and locks in place. One of the most exciting aspects of DLE is its synergy with geothermal power. Geothermal plants pump boiling hot brine from deep underground to generate carbon-free steam power. DLE can tap directly into this existing loop. Once the brine cools and generates electricity, it is fed into DLE filters to extract lithium before going back underground. From a financial perspective, DLE is a game-changer. While standard evaporation ponds only recover 40% of the lithium and brine, DLE captures over 90%. In addition, building a DLE facility costs a fraction of the capital expense of carving out giant evaporation ponds, meaning companies get more lithium faster for less upfront capital. Despite its advantages, DLE faces scale challenges. Washing lithium off the chemical beads requires a steady supply of fresh water, which can be scarce in arid locations. Additionally, geothermal brine is corrosive and hot, which degrades the chemical filters over time. Since brine chemistry is different at every site, companies must engineer custom filters for each well. DLE is moving from lab tests to commercial reality. Companies like Lilac Solutions are operating DLE systems in Argentina, while Berkshire Hathaway is developing extraction projects at California's Salton Sea. Geologists estimate the Salton Sea field alone holds enough lithium to supply the entire United States EV market for decades to come. Ultimately, DLE is about securing the battery supply chain. By using local geothermal wells, countries can produce battery metals close to their factories, avoiding long-distance shipping. Most importantly, DLE ensures that the electric vehicles we drive to protect the climate are built using minerals extracted with a minimal environmental footprint. Direct lithium extraction is transforming mining from an environmental liability into a clean, closed-loop technology. By harvesting lithium from geothermal wells in hours, DLE ensures we can build the battery-powered future we need without destroying the ecosystems we want to protect. What do you think about DLE? Let us know in the comments below. If you want more simple science explanations, subscribe to Layman's Field, bringing knowledge for everyone. We will see you in the next video.